This is a sample of one of the problems that you have in your 1D assignment. So a daring ranch hand sitting on a tree limb wishes to drop vertically onto a horse that's galloping under the tree. So maybe here's our tree, here's the branch that the ranch hand is sitting on, and there's a horse over here. You're going to have to bear with me on this one. So here's my stick horse with the mane riding this way. So the constant speed of the horse is 5 meters per second. So I know the velocity of this horse is 5 meters per second. Because it's a constant speed, I can also say that the acceleration is 0. And we want to know then what are we looking for? Probably looking for several different things. If the saddle is 2 meters higher, we know that this person, the dairy ranch hand, is going to drop by 2 meters negative because they're going down. We know also that because they're going up and down, that the acceleration of gravity is negative 9.8 meters per second squared. And we probably can also say that the initial velocity of the ranch hand is going to be 0 because they're just sitting up there in that tree. So she is going to fall down onto the horse at just the right moment to ride off into the sunset after having saved the day. Now, we can look at that and say, hey, I have 3 givens here. These 3 givens, I can find out the time that it's going to take the ranch hand for her to fall down, that is 2 meters. So I'm going to do x equals v it plus 1 half at squared. It's the equation that has everything except for the final velocity. My position is going to be that negative 2. The initial velocity is 0, so that cancels out. And I have 1 half of the negative 9.8 times t squared. And if I punch that into my calculator, then I'm going to have give me half a second here, 2 times 2 divided by 9.8. And then square rooting that, I'm going to get a value of 0.639. Now, if you forgot to put the negative here, what you would end up with is a negative under the radical, which says, hey, I missed a negative somewhere. And so those 2 negatives cancel out and become positive. So I know it's going to take the ranch hand that long in order to fall. Well, the next step is, well, how far away in the x direction does the horse need to be for her to fall off of the branch to actually land on the horse? Well, that length of time has to be the same for both of those. So I know that the time for the horse over here is going to also be the 0.639 seconds. And when I want to find that displacement, then notice that I have the exact same variable set, so I can say the exact same equation. X equals VIT plus 1 half AT squared. Looking for that position. The initial velocity is 5. The time it's going to take the horse is 0.639. And the acceleration is 0, so that whole term cancels out. And when I multiply 5 times that time, then I get a position of 3.19 seconds or meters that the horse has to be that far away in order for the range hand to land on the horse.